This is a Foundation Tier, non-calculator, GCSE Maths paper from 2023. I've been a software engineer and a private tutor for over 15 years. Let's see if I can do it. Okay, so this first question asks us to work out the range of these numbers. Range is easy. It's just the biggest number, take away the smallest. So in this case, the biggest number is 8, smallest number is 2, take them away, we're left with 6. So our answer is 6. Nice easy start there, we like that. Next one, it says work out 120, take away 89. We could say 89 is 1 away from 90, and then 90 is 30 away from 120. So 30 plus 1 is 31. Or you could just do the column subtraction. And then subtract like you normally would to make 31. Okay, next question. It says simplify 3 times a times 4. So when we have multiplication in algebra like this, we can multiply the numbers. So 3 times 4 is 12. And we also know in algebra, when a number is standing next to a letter, it means multiplication. So we can get rid of the times a and just make it stand next to the a. That means 12 times a. So the next one says measure the size of the angle marked x. So we need to use a protractor on this. I actually have a protractor on the screen. So what we do is we just line the protractor up, put the cross on the corner, and then we just count from 0. So if we go from 0, here's our 0. It goes through all of these and stops here. So the answer is 40 degrees. Okay, next question. It says work out 1/5 of 300. So to work out a fifths, there's 2 ways of doing it. You could multiply a fifth by 300. You could do 1 over 5 times 300. 1 times 300 is 300. 5 times 1 is just 5. So it's 300 divided by 5. So to work out a fifth of anything, you just divide it by 5. So 300 divided by 5 is 75. Next question. Question 6. There are 3 litres of oil in a can. Jermaine uses 700 millilitres of the oil. We need to work out the amount of oil left in the can. So we've got 3 litres. He's going to use some of it. So it's like a takeaway. He's taking it out of the can. So I think first of all, we need to put both of the values into millilitres. So 3 litres is 3,000 millilitres in the can originally. Then we need to take away the 700 millilitres that he uses. 3,000 take away 700 is 2,300. Millilitres, it says give our answer in millilitres. That's the milliliter answer, 2300 millilitres. Okay, we're on to the next one. Matt is drawing a scale diagram. 1 centimetre represents 5 metres. So on his diagram, when he draws a centimetre, that's going to represent 5 metres in the real world. He draws a 3 centimetre long line. What real distance does that represent? So this is just ratios. cms on the drawing to meters in the real world. 1 cm represents 5 meters. He's drawn 3 cm. So how do we get from 1 to 3? What are we multiplying by? We're timesing by 3. So we do the same on the other side. So that represents 15 meters. Next question. The real distance between 2 points is 20 meters. What's the distance between 2 points on the scale diagram? Okay, so same thing. We've got our cms, which is the diagram. And we've got our meters, which is the real. So the real distance is 20 meters. So first let's write our 1 cm represents 5 meters. The real distance is 20 meters. How did we get there using multiplication? We multiplied by 4, so we do the same on the other side. That's 4 centimeters on the diagram. Easy enough. Okay, question 8. Miss Bailey asked 24 students where they each wanted to go on a school trip. Here are the results. So we've got museums, we've got farms, we've got castles. And we've got to complete this frequency table. Okay, so let's start with the castle on the frequency table. So how many students wanted to go to the castle? We've got 1, 2 there. So we'll tally those in. We've got 2 more there. We'll tally those in. And when we're doing 5 on a tally, we cross through it. There's another 1, 2, 3, 4. 1, 2, 3, 4. 1 more there, and 1 more there. So I think I've got all the castle ones. Okay, next one. Farm. So let's see how many want to go to the farm. There's 1. There's 2, 3, 4. So let's tally those 4. There's a 5th one, and again, when you're tallying 5, you cross through. 1, 2 more there. Okay, and that's all the students that want to go to the farm. And lastly, the students that want to go to the museum. 1, 2, 3. 1, 2, 3. 4. Again, tallying 5, cross through. And 6. I've got all of the students tallied. Okay, next, we need to add them up. Okay, so the castle. We've got 2 sets of 5 and a 1. That makes 11. Remember, each one with a cross through is a 5. So we need to count them. We just know. Farm, we've got a set of 5 and 2, which makes 7. And museum, we've got a set of 5 and 1, which makes 6. Simple. Okay. Write down the place that is the mode. So mode is the one which is the most. Okay. In this case, the place which is the most chosen. Okay. So the mode in this question is the castle, because the castle is chosen 11 times. In this case, it wants us to write down the place, not the number. So we don't write down the 11, we write down the word castle. So draw a bar chart to show these results. Okay, so I'm going to draw a bar chart. So it's castle 11, farm 7, museum 6. So we've got to demonstrate that on this grid. So the largest number we need is 11. So this has got to go up by 11. So let's see if it does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's all we need, because we only need to go up to 11. That's fine. I think we can work with that. A bit of a pro tip there. Before you start drawing a bar chart, try and organize your axes. So the y-axis going up and the x-axis going across. Make sure they work first. Then it becomes a lot easier to draw the little rectangles. Okay, so we've got our y-axis, which is the frequency, let's say. So maybe we'll write that down. Frequency. And across the x-axis, we're going to put castle, farm, and museum. So we need 3 items across the x-axis. Let's see how we would fit those in. So our x-axis seems to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So if I did 3 for each one, so 3 for castle, 3 for farm, 3 for museum, I think they'll fit in quite nicely. Again, organizing my axes first. So let's start with the castle, which is 11. Okay. So up to here, we'll have castle. Okay. So that goes all the way up to 11. So we need a full bar of 11 there. That'll do. Okay, so the next one is a farm, which is 7. So let's draw that in as well. And again, 3 squares along the bottom. Farm, and that's going to be 7. Okay, so we've got farm, and the last one there is museum, which is 6. So let's draw museum. And again, 3 along the bottom. Museum. And this one is going to be 6. And there's no obligation to use all the squares along the bottom and all the squares along the side. We just have to use the space effectively. Okay? So if I only used 1 square for each bar along the bottom, that wouldn't be effective. It would leave too much space. But because I've filled it as much as I can, that's acceptable. Okay, next question. Selena has a bag of 22 counters. 5 of the counters are blue, 9 of the counters are red, and 8 of the counters are pink. Selena takes a random counter from the bag. Write down the probability that Selena takes a red counter. So probability is just, it's real simple. Probability is just like this. It's the thing that you're choosing out of all the things. So I think about it like this. Thing to choose out of everything. So the first question says she's choosing a red counter. So how many red counters are there to choose from? There's 9. So that's our top number in our fraction. And everything, so how many counters are there altogether? It says there's 22, so it's 9 out of, so red counters, out of everything, which is 22. Simple. Part 2 says, what's the probability that she does not pick a pink counter? So not picking a pink counter is everything other than a pink counter. So blue and red are not pink. Okay, so blue is 5, red is 9. So those are the things we can choose. 9 and 5 makes 14. And again, out of everything, and everything stays the same in this one, it's just 22. And the probability that she takes a white counter, well, are there any white counters in the bag at all? No. So there's 0 probability. 0. It's that easy. Question 10. Here are the ingredients to make 20 peanut butter cookies. Derek wants to make 60 cookies. Okay. He has 900 grams of peanut butter. Does Derek have enough peanut butter to make 60 cookies? Well, let's take a look. So, to make 20 cookies, how much peanut butter does he need? He needs 250 grams of peanut butter for 20 cookies. So let's write a ratio of cookies to peanut butter. Okay, so cookies to peanut butter. So if he wants to make 20 cookies, as it says in our recipe, the ingredients list, if he wants to make 20 cookies, how much peanut butter does he actually require? Well, in the question, it says he needs 250 grams for 20 cookies. 250. I'll write grams here so we remember. Okay, so for 20 cookies, he needs 250. So the question is, how many grams of peanut butter will he need for his 60 cookies? And he's planning to make his 60 cookies. How many grams of peanut butter should he weigh as a minimum? So what are we doing here? How do we get from 20 to 60 using multiplication? We're timesing it by 3. So the same thing happens on this side. Multiplying it by 3. You can do column multiplication if you want to. 250 times 3, I know, is 750. So we know that Derek needs to weigh 750 grams of peanut butter. So he goes to his jar. His jar has 900 grams. So his jar of peanut butter's got 900 grams in it. Can he take 750 from there? Yes, he can. He's got a lot more than he needs. So does he have enough peanut butter? Yes. He has more than he needs. Good. Okay. Next question. On the grid, draw an enlargement of the triangle with a scale factor of 3. Okay, so what is scale factor? Scale factor just means the multiplier, the thing that you're multiplying by. So how can we enlarge this triangle with a scale factor of 3? So the way I do it is this. I find an easy side. So I'm not going to use this side because that's difficult. Okay, I'm not going to use a diagonal. Diagonals are difficult to use. What I'm going to do is I am going to use this side here. So we know that this side is horizontal and it's 2 squares. So if we times that by 3, it's going to be horizontal and 6 squares. So let's do that. So we can find a nice space on the grid. This one doesn't tell us where to draw it, just says draw it. 1, 2, 3, 4, 5, 6. Normally you would use a ruler. I'm working quickly. So we've got this line, which is 6. Now, what about the rest of the triangle? Because that's not a triangle. We need to draw the rest of it. So next thing I'm going to do is I'm going to find another straight line that I can use. I don't want to use a diagonal. Diagonals are confusing. Okay, let's use another straight line. So the easiest straight line I can see here is this one that goes through the middle. So we know that this line is going through the middle of the blue line. So we know where it starts. It has to start in the middle of the blue line. And again, scale factor is still 3, so we have to multiply it by 3. So it's vertical and 3 squares. Times it by 3 is vertical and 9 squares. So we need 9 squares for that middle line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I've drawn this very close to the top, but that doesn't matter. Okay, so we've got the middle. Now, that's not technically a line in the diagram. I'm using it to help me to construct the triangle. Because now, all I need to do is join those points together to construct my triangle. So here's the first line. And the second one. Goes here. And I might even tidy up the horizontal line as well, because it does not look very good. And I think we are done. We've got this perfect triangle, which is scale factored by 3. Okay, question 12 says, P equals 2G plus 4H. Work out the value of P when G is 3 and H is 5. Okay, in this one, let's write down what it's saying. P equals 2G plus 4H. It says G is 3 and H is 5. Okay, so in algebra, when we have a number standing next to a letter, so this number standing next to this letter, it means multiply. And the same goes for this one here. This one also means multiply. So what this is actually saying is P equals 2 times G add 4 times H. And we know G and H because the question tells us. It tells us that G is 3. So I can replace the G with a 3 and I can replace the H with a 4. Okay, so now we just work it out. 2 times 3 is 6, 4 times 4 is 16, add them together, P must be 6 plus 16. 6 plus 16 is 22. Okay. Work out the value of G when P is 38 and H is 3. Okay, so same equation. P equals 2G plus 4H. Okay, but this time it doesn't give us G, it gives us P. So let's write it down. So it tells us P is 38. And we remember that 2G means 2 times G, and 4H means 4 times H. Okay, because letters stand next to numbers mean multiply. They have to be. Okay, so it tells us H as well. H is 3. So maybe we can rub that out and write that down. Because H is 3, it tells us H is 3. Okay, so now we can start working some things out. We know the 38. We don't know the G, so we'll leave that like it is. And we know 4 times 3 is 12. Okay, so far so good. Now using algebra, we can move things from the right-hand side to the left-hand side. Okay. So if I subtract 12 from here, that goes away, and I do a subtract 12 on this side. So 38 take away 12 is 26. And now I've got 26 is 2 times G, or 2 times something is 26. So how are we going to work that out? Well, we got times 2. The opposite of times 2 is divide 2. So if I divide 2, that goes away and divide it on this side. Therefore, G is 26 divided by 2. 26 divided by 2 is 13. Okay, next question. So we're given a new equation, V equals 3R minus Q. We've got to work out the value of V when R is negative 3 and Q is 2. Okay, so let's write that down. V is equal to 3R minus Q. Okay, so first things first, we've got a letter standing next to a number. So again, we know what that means. Letter with a number means multiply. So that 3R is actually 3 times R. And then we've still got our minus Q on this side here. Okay, so far so good. Now we can put some numbers for the letters. So again, it tells us that R is negative 3. So let's replace the R with a negative 3. Okay, then it tells us that Q is 2. So let's replace the Q for a 2. Okay, now we can start working some things out. Okay, so first of all, we have this multiplication. Now, according to bed maths, we have to do the multiplication before the subtraction. So let's do the multiplication first. 3, or positive 3, because that 3 doesn't have a sign, so we pretend it's positive. Positive 3 times negative 3. So when the signs are different, the answer is always negative. 3 times 3 is 9. Then we still have our minus 2, or take away 2. Okay, so minus 9, take away 2. If we think about our number line very quickly, so if this is a number line, if I have 0 over here and minus 9 over here, take away means we're moving to the left. So minus 9, take away 2 means go this way. Take away 1, take away 2. Okay, so that's minus 10. This one would be minus 11. So V equals minus 11. Okay, next question. Chloe's making scrunchies. Chloe has a large number of hair bands. Each band costs 8p. She buys 100 grams of wool for £3. Chloe uses 1 hair band and 5 grams of wool to make each scrunchie. She makes as many scrunchies as she can. Work out the total cost of each scrunchie that she makes. Give your answer in pence. Okay, so there's a lot happening in this question. So let's break it up a little bit. Okay? So I think I'm going to start with the fact that a hairband is 8p. Okay? So hairband. I'm going to call that HB, is 8 pence. So far, so good. And 100 grams of wool is £3. So 100 gram wool equals £3. Okay, so what is the cost of making one hairband? So to make one hairband, no. So what is the cost of making one scrunchie? So according to Chloe, to make one scrunchie, so one scrunchie is equal to using one hairband, so one hairband, and 5 grams of wool. 5 grams of wool. Okay, so that's how we're going to make a scrunchie. So if we can work out the price of one hairband and 5 grams of wool, we know the cost of making a scrunchie. Okay. So one hairband's really easy. It tells us that each hairband is 8 pence. So that one's simple. 8 pence. We've done that one. Okay, what about 5 grams of wool? Well, we know that wool is £3 for 100 grams. So again, that to me sounds like a ratio. If I go grams to, and I'll do it in pence. Okay, so 100 grams is £3, but I want to change it to pence. So pounds to pence is 100, so 300 pence, which is £3. And I need to get to 5 grams of wool. So I'll put that here. How am I going to do that? So how do I get from 100 to 5? I think that's divided by 20. So I do the same divide by 20 on the other side. So 300 divided by 20 is 15. So 5 grams of wool costs 15 pence. Okay, so I've got my pence for my 5 grams. So 15 pence. And that is how much one scrunchie costs, which is both of those together because you have to use both of them to make a scrunchie. So 8 pence plus 15 pence is 23 pence. Let's check if that's what the question wants us to do. Work out the total cost of each scrunchie that she makes. Costs her 23 pence. I'm happy with that. Okay, let's keep going. Question 14 says, on the grid, draw a graph of y equals 4x minus 1 for the values of x from -2 to 2. Now looking at this, I believe they want us to draw a table in this area here. They've given us all this space to draw a table. Now, to be honest, we don't actually need a table to draw this graph. It says y equals 4x minus 1. So the -1 tells us the y-intercept. So where does it cross that y-axis? It crosses at -1. So if I put a point there, so we know that it's going to cross the y-axis at -1 because it tells us in the equation. Then it says y equals 4x minus 1. So 4x tells me that the gradient is 4. So we have to be a little careful here because units across on this graph are 2 squares, but units up and down are 1 square. So when doing the gradient, we need to do 1 unit across, 4 units up. So if I do 1 unit across, which is 2 squares, and then 4 units up, which is 1 square each. So 1, 2, 3, and 4. So our next point is going to be there. And we can do that again because we have some space on this graph. So again, 1 unit across, which is 2 squares, and then 4 units up. 1, 2, 3, 4 squares, and there we are. Okay, so we can erase all these arrows now. Okay, and we can also do that like backwards as well, going downwards. So 1 unit across, 4 units down. And the same thing applies. 1 unit is 2 squares, and 4 units down. 1, 2, 3, 4. And the same again, 1 unit across and 4 down. 1, 2, 3, 4. So there's our last point. And let's erase all the arrows. Okay, so those are all the points that I need for this graph. So we can now just join them together. So it should look something like this. I'm now going to draw the table, and let's see if I got it right without the table. Okay, so the table should look something like this. It should have an X row and a Y row. So let's start with X. So a row of X and a row of Y. If I draw a table out of that, and it needs to go from -2 to 2. So the X values need to start at -2 and finish at 2. So if I start at -2, then go to -1, then go to 0, then go to 1, I need some more space, and then to 2. Okay, so this is the beginnings of our table. Okay, so for each of these, we need to work out the Y value. So how do we do that? What we do is we just substitute X into the equation. So let's start with a really easy one. Let's start with 0. So when X equals 0, so if I put 0 here, that means 4 times 0, which is 0, and then we have to take away 1, which is -1. Okay, next one. Let's go from the beginning. X is -2. So this one here, X is -2, so 4 times -2 is -8. -8 minus 1 is -9. Okay, next one is -1. So when X is -1, what's Y going to be? 4 times -1 is -4. -4 minus 1 is -5. Okay, next one is 1. So when X is 1, what is Y? So if X is 1, what is Y? So 4 times 1 is 4. Take away 1, Y's got to be 3. And the last one, when X is 2, what's Y? 4 times 2 is 8. Take away 1 is 7. Okay, so I've got all my table filled in. Now let's see how that relates to my graph. So each one of these is coordinates. So we've got X and Y, which are coordinates. So let's have a look at this one first. Those are coordinates. That's like saying -2, -9 in coordinates. So X is -2, Y is -9. Does that work on my diagram? I think it does. For this point here, the X is -2 and the Y is -9. Next one. X is -1 and Y is -5. Same again, let's take a look. X is -1 and Y is -5. For that point there, I think it's correct. And then the next one. X is 0, Y is -1. And again, I think I'm correct. That point in the middle, X is 0, Y is -1. And then the next one. X is 1, Y is 3. So X is 1, but Y is 3. For this point here, I seem to think it works. And the last one, X is 2, Y is 7. And does that last one work? I think it does. X is 2 and Y is 7. Okay, next question. Steve is buying a car. The car costs £12,000. Steve pays 25% of the car as a deposit. He pays the rest of the cost in 20 equal monthly payments. We've got to work out how much each monthly payment is. Okay, so his starting price, the price of the car is £12,000. So I'll write that here. So that's how much money he has to pay. He gives them 25%. So 25% is a quarter. So a quarter of 12,000 he gives as a deposit. So let's work that out. 1/4 of 12,000, which is at 25%. 25% is 1/4. So a quarter of 12,000 just means divide 12,000 by 4. So 12,000 divided by 4, that's 3,000. He gave them £3,000 as a deposit. Okay, so let's put that in our calculation. So £3,000. And I'll write deposit next to it. Okay, so he's given them that much money already. So how much money does he have left to give them? We can do a takeaway. We take them away. If we take them away, 12,000 take away 3,000, the amount of money he still has to pay is 9,000. Okay? To pay. I'll write down to pay next to it so I remember what the words mean. Okay, so we've got £9,000 left to give them to buy his car. He's going to pay that in 20 monthly payments, and each month is going to be equal. So he's got to divide that into 20 months. Divide it into 20 months, that's a division. So we're going to divide that by 20 months. Divide 20. Okay, so 9,000 divided by 20. I'm going to simplify this first so I can divide both of these by 10. So it's 900 divided by 2. I know 900 divided by 2 is 450. So every month he needs to pay £450 per month. So that's how much money he's got to pay every month to pay off the remaining £9,000. Next question, Shah takes an exam. The exam is out of 60 marks. Shah needs to score at least 70% of the marks to pass the exam. He scores 45 marks. Show that Shah passes the exam. So it's telling us that he's passed, but we need to prove it. We need to show them that he's passed. So he needs 70% to pass. So it's got to be more than 70% that he's scored. If we get a number less than 70%, we know we've got it wrong. Let's take a look though. So he scored 45 marks out of 60 marks. And we need to try and turn that into a percentage. So the easiest way to turn any fraction into a percentage is trying to get it out of 100. If it's some number out of 100, that fraction automatically becomes a percentage. So for example, it was 12 out of 100. That's 12%. If it's out of 100, your numerator is your percentage. Okay? If it was 37 out of 100, that's 37%. So the easiest way is to make it over 100 somehow. So let's see if I can make this over 100. If I make it over 20 first, if I can do that, I think I can, because both of these divide by 3. So this divides by 3, and so does this one. Because in fractions, when we're simplifying, whatever we do to one of the numbers, we must do the same to the other number. Divide by 3 is 15. Okay, so now it's out of 20. And I know that 20 goes into 100. So how can we make 20 into 100? We multiply by 5. Do the same here. Multiply by 5. That makes 75. And what did we say earlier? Anything over 100 is a percentage. The numerator is the percentage. So that's 75%. So how do we know that he's passed? The pass mark was 70%. He scored 75. So we've shown that he's passed. 75% is greater than 70%. Done. Okay, work this out, which is 3/5 divided by 1/6. Give your answer as a mixed fraction. Okay, so when we're dividing fractions, we've got to flip the second fraction. We've got to multiply, and we've got to keep the first one the same. And then we work it out. So 3 times 6 is 18. 5 times 1 is 5. So now we've got this improper fraction. The top number is bigger than the bottom number. We've got to change this to a mixed fraction. How are we going to do that? It's really easy. How many 5s go into 18? 3. What's the remainder? 3. And that denominator stays the same. Done. Question 18. 6.3 times 2.4. So the easiest way to do decimal multiplication is to ignore the decimals. Pretend they're not there. So I would do 63 times 24. There's loads of ways of doing multiplication. You can do it however you want. So I'm going to work this out my way. 3 times 4 is 12. 3 times 2 is 6. 6 times 4 is 24. 24 plus 6 is 30. Add the 1 makes 31. And then 6 times 2 is 12. Add 3 is 15. So I've done the multiplication. But what about those decimals in the question that we ignored? What we do now, after we've done all the multiplication, we go back to the question. And we have a look at the question and think, how many numbers are after decimals? Like, how many of those digits are actually after a decimal? So I've got 1 here, and I've got 1 here. So altogether, I've got 2 digits after decimals. So in my answer, I need 2 digits after decimals. And I'm done. That's the answer. Next question. 19 says, write down the value of 5 to the power of 0. So anything to the power of 0, you don't need to work it out. If it's to the power of 0, it has to be 1. It's an easy one to do. Just remember, any number to the power of 0 has to be 1. Part 2. Write down the value of 5 to the negative 2. Okay, so negative 2 as a power is a bit weird. But the best way to do this is to ignore the negative, okay? Just do it like a normal 5 to the power of 2. Because we know 5 to the power of 2 is 25, okay? And then the negative just turns that into a fraction with 1 at the top. So the fact that we have a negative there means turn it into a fraction, but keep the bottom number the same as the number you just worked out. Okay, the next one. Right, 2 to the power of 5 times 2 to the power of 4 over 2 to the power of 3 in the form 2 to the n, where n is an integer. So what it's asking us to do is to simplify all of this and just make 2 to the power of some number. Okay, let's do this. So I'm going to focus on the top half first. So let's write this down. It says 2 to the 5 times 2 to the 4. And then the denominator says 2 to the 3. Okay, so the top half, the numerator, 2 to the 5 times 2 to the 4. When we're multiplying and our base numbers are the same, we need to add the integers. So 5 and 4 make 9. So that's 2 to the 9. Okay, now we have this divide. Remember, a fraction just means a divide. And when we're dividing, we do the opposite. So times was add them. Divide must be take away them. So this is the same as 2 to the power of 6. And there we are, we've got it. We've got 2 to the power of a number. Okay, next one. Question number 20, write 156 as a product of its prime factor. So this is we're going to have to draw a prime factor tree. So we start with our 156 right at the top there. 156. And we think, hey, what numbers can I multiply to make 156? And if you're not sure, the easiest thing to do is check if it's an even number. If it's an even number, it'll always divide by 2. Okay? So let's divide it by 2 to keep it simple. We have a 2, and how many 2's go into 156? You want to do bust up, you can do bust up if you can. I would say it's 78, I think. And again, if I'm wrong, tell me. And again, the 78 is a big number, but I notice it's an even number, so I'm just going to do another divide by 2. Every time it's even, and I'm not sure, I'll just divide by 2. So that's 39. Okay, so 39 now is not an even number, but I know that 39 divides by 3. That makes 13. Okay, can we continue this? Now, I think every branch ends in a prime number, so there's nothing to continue. So that's the aim of the game here, is to keep branching until you reach prime numbers, and you can't branch anymore. So now what we need to do is we need to find all these prime numbers and multiply them together. So this one is a 2, this one is a 2, this one is a 3, this one is 13, and now we need to multiply them all together. Okay, so how can we simplify that? Can we simplify this multiplication at all? So 2 times 2, I think I can make that into 2 squared. 3 and 13, there's nothing I can simplify there, so I'll just leave it like that. And that is our answer. The mean length of 5 sticks is 4.2 centimeters. Nawal measured the length of one of the sticks as 7 centimeters. We need to work out the mean length of the other 4 sticks. So we've got 5 lengths. These are going to be boxes where I'm going to write numbers. So how do we work out the mean of those numbers? We don't know what the numbers are yet, but how do we work out the mean? Well, we add them up. And we get a total of all those numbers. And then we divide by how many numbers there are. So how many numbers are there? Well, there's 5. So we divide this by 5. And it tells us the mean is 4.2. So that's that one there. 4.2 cm. Okay, so now we can work backwards. Because if we know the mean is 4.2, and how do we get the mean? We do total divided by 5. So some number divided by 5 is 4.2. So all we need to do is multiply 4.2 by 5. So 4.2 by 5 is 21. So now we know the total has to be 21 centimeters. That's the total of all the sticks put together. So far, so good. But then it tells us that one of the sticks is 7. So this one, let's say, is 7. So if all the sticks added together is 21, and one of them is 7, what do the remaining sticks added up have to make? Well, something plus 7 is 21. So altogether, they must be 14. Okay, so the total of those ones, just these ones, must be 14. Okay, so if I put an equals, the total divided by, well, there's 4 now, equals the mean. Well, we know the total. We've just said it's 14. So 14 divided by 4 must equal the mean. 14 divided by 4 is 3.5. And that's the mean of the remaining 4 sticks. Okay, let's keep going. Nawal made a mistake. The stick was not 7 centimeters long. It was 17 centimeters long. How does this affect your answer to part A? Well, let's take a look. So they're saying that he made a mistake here. Let's put our 4 boxes back in. They said that he made a mistake on the 7. It's not 7, it's 17. So what's that going to do for this number? Well, if the 7 becomes 17, then the 14 is going to get a lot smaller. It's going to become 4. If the 14 becomes 4, then 4 divided by 4 will be 1. So the other sticks become shorter, I think is the answer. The mean of the remaining sticks becomes shorter. So the total becomes less, the total divided by the same number, therefore the mean becomes smaller. Question 22 says, point P lies on line AB. Use a ruler and a compass to construct an angle of 90 degrees at P. Show all your construction lines. So I'm working on an iPad screen at the moment, so that's going to be a little difficult to do this question. My drawing might be a little inaccurate, but I will explain the steps as I go through it. So I think this is a little bit of a red herring, that they're telling you line AB, and P is not in the middle of that. So it's going to be very difficult to use points A and B, but we can create some new points. How do we create new points? What we do is we use P as the center of a circle. So we draw a circle around P. Here's my circle around P. You notice where it crosses through the line, I've got 2 new points. The difference here is that I know that P is exactly in the middle of those 2 points. It's not in the middle of A and B, but I've made 2 points using the circle. Okay, so now what we're going to do is we're going to increase the size of our compass. We're going to make a compass a lot bigger. It's got to be more than the radius of P, of the green circle. So we're going to make our compass a little bigger, and we're going to draw 2 new circles, one around the red point and one around the blue point. So here are our 2 new circles. Notice that they are bigger than the green circle. We open the compass up a little bit. We've drawn one around the red point, one around the blue point. We notice that we've got these points that cross now. Notice how the green, the red, and the blue cross at 2 points. That there, if we join those 2 points up, will create a perpendicular line to the other line. So let's join them up like that. What we have created is a 90-degree angle at P. And we leave those construction lines where they are. We don't rub them out because the construction lines are part of the working out. Question 23. The diagram shows an isosceles triangle ABD and a straight line ABC. It tells us that BA is equal to BD. XY is 2, 1. Work out the value of W. Okay, so let's start by understanding the question. ABD is a triangle. Where is that? ABD. Okay, I understand where the triangle is. ABC is a straight line. Where's that? That's that straight line there. That makes sense. Then it says BA is equal to BD. BA is this line here, and BD is this line here. Again, that makes sense because it's an isosceles triangle. Those 2 sides have to be the same. They've got the little lines on them to tell us that they are the same. So these lines here tell us that those 2 sides are the same. Then it says x to y is 2 to 1. So x to y is 2 to 1. So is it saying that x is 2 times larger than y? That's interesting. And we need to work out the value of w. So we're trying to work out this angle here, which we don't know. Okay, so what I like to do with these ones, I like to work backwards to develop a method. Like we need to know how we're going to get to w. So if we work backwards, we'll have a path. So looking at w, I can notice that w is on a straight line. The fact that w is on a straight line is if I know y, let's pretend that y was a number. If I know y, then I can work out w by taking away from 180. but I don't know y yet. Okay, so I think the goal here is to work out y. Once we've worked out y, we can take away from 180 and then get w. Okay, so how are we going to work out y? Well, I think we need to use this information here. X to y is 2 to 1. Okay, so let's write that down. X to y is 2 to 1. Okay, so that's like saying x is 2 times bigger than y. Because another way of writing that, if we write that in algebra, is x is equal to 2 times bigger than y, so 2y. Okay. But do we see any more angles which could also be x on the diagram? I think we do. I think because we know that this is an isosceles triangle, the base angles have to be the same. So I think this one here is also x. Okay, so inside that triangle, I have 2 x's and 1 y. Okay, so I've got 2 x's, so I have an x, another x, and a y. But what did we say? We said that x is equal to 2y. So I can replace these x's with 2 y's. Okay, so how many y's are inside the triangle? 2y add 2y add y is 5 y's. So inside that triangle, I have 5 y's. And a triangle we know equals 180. If a triangle is 180 and the triangle is 5 y's, how much is y? We just need to divide it. So 180 divided by 5. So I think that's 36. Okay, so now we know what y is. Well, what did we say earlier? If we know what y is, we can also work out w by taking away from 180. So w is 180 take away 36. Therefore w has to be 144 degrees. Next question. Mano has 3 shelves of books. There are x books on shelf A, 3x plus 1 on shelf B, 2x minus 5 on shelf C. There's a total of 44 books on the 3 shelves. All the books have the same mass. The books on shelf B have a mass of 7,500. Work out the total mass of the books on shelf A. I think we need to first work out how many books are on shelf B. And to do that, I think we need to work out x, because if we know x, we can just work out the books on shelf B. So to work out the value of x, we know that there's 44 books altogether. So I think we need to add up x, 3x plus 1, and 2x minus 5, make it equal to 44, and then do some algebra to work out x. So let's try that. So first we're going to add up all of these. So we've got x plus 3x plus 1 plus 2x minus 5, and we're going to make that equal to the 44 books, because there's 44 books altogether. So now, we can now work out this algebra. We can work out the value of x. So how many x's do I have? I have 3x, 2x, and 1x. That makes 6 x's. And what else do I have? I have a plus 1 and a minus 5. That makes minus 4. And that's still equal to 44. Okay, so now we can add 4 to both sides to get rid of that. So 6x equals 48. And if 6x is 48, we know that x then has to be 8. So if x is 8, how many books are on shelf A? Well, there's only X, so X is 8, so that's 8 books for shelf A. How many books on shelf B? That's 3x plus 1. X is 8, times it by 3 is 24, plus 1 is 25. And then how many books are on shelf C? 2x minus 5. X is 8, times by 2 is 16, take away 5 is 11. And we can check that. 8 plus 25 plus 11 should equal our 44 books. Does it? I think it does. So let's keep going. So now we know how many books are in each shelf. I think now we need to work out the mass of one book. It tells us that the books on shelf B have a mass of 750. So we're going to focus on shelf B. Okay. So shelf B is 25 books. 25 B for books, let's say, is equal to the 7,500 altogether on that shelf. So now we can work out the value of one book, or B, by just dividing by 25. So 7,500 divided by 25. So the mass of one book is 300, I think. Okay, so if one book is 300 grams, and it tells us that all the books have the same mass, so they all weigh the same. Every book on every shelf weighs the same as every other book on every shelf. We need to work out the mass of the books on shelf A. How many books are on shelf A? There are 8 books on shelf A. Each book is 300 grams, so we times that by 300 grams, which altogether makes 2,400 grams. So that there is the mass of the books on shelf A. A piece of glass has a mass of 27 grams and a volume of 10 centimeters cubed. Work out the density of this piece of glass. So density is an easy one. We just need to know the formula. The formula for density is density equals mass over volume. So what do we know? We know the mass. The mass there is 27 grams. And the volume, or we know the volume is 10 cm squared. So all we're going to do is we're going to divide this. So density is 2.7 grams per cm squared cubed. Okay, work out an estimate for this. 5.7 times 8.2 divided by 0.26. So an estimate means you're not working out anything exactly. You need to change the numbers into easier numbers so we can work them out. So let's start with the 5.7. 5.7 is really close to 6, so I'm going to call it 6, not 5.7. 5.7 is a difficult number. Let's make it easier for our estimate. 8.2, again, how can we make 8.2 into an easier number? Estimate means make it into an easier number. 8.2 is very close to 8. And then we need to divide. Okay, 0.26. Well, 0.26, I'm going to change that into 0.25. Because dividing by 0.25 is like dividing by a quarter. Okay, so now we can start working this out. 6 by 8 is 48. And we're dividing by 0.25. So there's a few ways of doing this. Divide by a quarter is just like saying fraction, right? So what is this saying? This is saying 48 divided by 0.25. 0.25 is a quarter, so we can change that into a fraction. And 48 into a fraction is just 48 over 1. So we can do this like we normally do fractions. Flip the second one and multiply. 48 over 1 times 4 over 1, second one's flipped. And now we just do 48 times 4, 192. Another way of doing this question is to multiply both of these by 4, you get 192 over 1. 192 divided by 1 is just 192. So a few ways of doing the question there. Question 27, it says expand and simplify, so expansion. So this is algebraic expansion. So the question says 3x plus 2 times 2x minus 5. Okay, so the first one is we multiply this one and this one. That is 6x squared. Next, what we do is we multiply this one and this one, which is positive 4x, and then we multiply this one and this one, which is negative 15x. And then lastly, we multiply this one and this one, which is negative 10. And then we simplify this a little bit. Notice those blue ones can be simplified. We can put them together. Positive 4x, take away 15x, is negative 11x. So altogether, we've got 6x squared, negative 11x, negative 10. So we've expanded it, and we've simplified it. Okay, so the next one says factorize x squared minus 16. So in this one, the root of x squared is just x, the root of 16 is 4. We write that twice. And then, because it's a minus in the middle, we have a plus and a minus. And that will expand to make x squared minus 16. And that was our last question. The paper's done.
And if you want to dive deeper into any of the topics discussed in this video, visit the website protutor.ing or send me an email, hello@protutor.ing, for more information. As a tutor with over 15 years of professional experience, I can help you build a strategy to maximize your results and achieve your goals. Also, don't forget to like the video and subscribe to the channel so you don't miss out on the next video.